Okay, I'm going to show you guys how to do an ice diagram, and I call these simple ice diagrams. So this is problem 1311 from the book in the text, and the first thing we need to do is come up with a balanced equation. So we're going to go ahead and read through the problem and create our balanced equation. And when you have your balanced equation, make sure you include the state of matter and the correct coefficients. The next thing we're going to do is find the concentration of everything in our balanced equation. We'll do that by reading the problem. It says we have 3 moles and 1.5 liters for each of the substances. So I'm going to go ahead and write out their concentrations. Now that we have the concentrations, we're going to go ahead and write our Q expression using our balanced equation. And then we will plug in our concentrations to our Q expression. So we've got 2 squared on the top, and then we have 2 times 2, which is also 2 squared on the bottom, and this would equal 1. Next, we're going to compare our Q to our K. Our K was given in the problem as 1.15 times 10 to the second. Another way to write that is 115. So our K is greater than our Q, because 115 is greater than 1. This means the forward reaction is favored. Our products are favored. So your products are going to get a positive sign when we do the ice diagram, and our reactants are going to get a negative sign in the ice diagram. So I've plugged in my equilibrium formulas, and then I've made this. Now this is an easy problem. We're going to solve it by squaring, getting the square root of everything. So if I take the square root of this guy, the square root of this guy, and the square root of this guy, I can get 10.7 equals 2 plus 2x on the top and 2 minus x on the bottom. And now I'm simply going to use algebra, we all love algebra, and solve for x. So go ahead and do that, and then check back with what the answer is. Okay, so hopefully you have done the work, and you've found that x equals 1.528. The last thing we're going to do is plug in this with our E up here. And so my concentration of H is the same as my concentration of F, and that value equals 2 minus 1.528, which equals 0.472 molarity. And then my concentration of my HF, I plug that into this formula, so I'm going to do 2 plus 2 times x, and I get 5.056 molarity for my concentration of HF, and those are our final answers. We'll just circle it and we're done.